Hello everyone and welcome back to our channel. Today we're diving into the alias function in PySpark, a powerful feature that allows you to rename columns easily while performing transformations on your data frame. Whether you're doing simple selects, complex aggregations, or need to clarify column names after joins, alias is a handy tool that makes your data more readable and your code more intuitive. Stick around as we explore how to use this function to improve the clarity and structure of your data frames in PySpark. Introduction to the alias function. The alias function in PySpark is a versatile tool that allows you to assign a temporary name or alias to a column within a data frame. This function is particularly useful when you need to rename columns during data transformations or while performing operations such as select, group B, or with column. By using an alias, you can easily give a more meaningful or descriptive name to a column, making the data easier to understand and work with, especially when dealing with complex transformations. One of the primary benefits of using alias is to avoid column name conflicts. For example, when joining multiple data frames, you might end up with columns that have the same name. In such cases, assigning aliases to those columns can help differentiate them and prevent ambiguity. Additionally, using alias improves the readability of your code by allowing you to create clear descriptive names for calculate columns or results of transformations, making your analysis easier to follow. The alias function doesn't change the original column name in the data frame permanently. Instead, it provides a temporary name that is used for the duration of the current operation. This is helpful when you want to create a custom name for a specific operation without modifying the underlying schema of the data frame. Overall, alias is a handy tool for enhancing the clarity and structure of your data, enabling you to work more efficiently when transforming or analyzing your data frames in PySpark. Basic syntax. The basic syntax for using the alias function in PySpark is column.alias new name. In this syntax, the column represents the column in the data frame to which you want to assign a new alias, and new name is the name you want to temporarily assign to that column. The new alias provided is not a permanent change to the column name in the data frame. Instead, it is used only for the duration of the current operation of transformation. This allows you to rename columns as needed without modifying the original data frame structure. The parameter new name is the temporary alias that helps provide context and clarity during specific operations. For example, when selecting or grouping columns, giving an alias can make your output more descriptive and easier to understand. Using alias is particularly helpful when performing complex transformations such as aggregations or joins, where columns may have identical or confusing names. Assigning aliases helps differentiate columns, avoid ambiguity, and improve the readability of your code. By using alias, you can make your data frame operations more intuitive and informative, allowing you to focus on the intended analysis without worrying about name conflicts or confusion. It enhances the clarity of the transformation being performed, providing meaningful, user-friendly names are friendly, the resulting data frame easier to work with. Why use alias? The alias function in PySpark is incredibly useful because it allows you to make columns easier to reference in complex queries and transformations. When working with large datasets, especially in scenarios that involve multiple transformations or data aggregations, the default column names can often become unwieldy or confusing. By assigning an alias, you can give columns simpler, more meaningful names that are easier to understand and reference, which is particularly beneficial in making your code more readable and manageable. Aliases are also useful when you want to provide more context to your data, such as renaming columns to indicate the specific role they play in your analysis. For example, when performing joins between multiple data frames, Column names may become ambiguous if both data frames have similar column names. Using alias helps avoid this confusion by giving each column a distinct, descriptive name that clearly differentiates its origin or purpose. This is especially true when performing aggregation functions such as sum, add, or count, where providing an alias allows you to easily interpret the resulting output. Additionally, using alias makes it easier to work with columns programmatically, allowing you to refer to them more conveniently throughout your code. Whether you're using it for selecting specific columns, performing group operations, or joining multiple datasets, the alias function helps improve the clarity of your operations by removing ambiguity and providing user-friendly labels. This not only helps in debugging and maintaining your code, but also makes collaboration with others much smoother as the renamed columns provide clear context about the transformations being performed. Practical examples. So, 1. Renaming a single column. In this example, we are working with a PySpark data frame DEF that contains employee information, including employee underscore id, name, and salary. We start by creating the data frame using the create data frame function, where each row represents an employee's details, including their unique ID, name, and salary. This structured format allows us to easily perform various data operations. To rename the salary column, we use the alias function to give it a new name, employee underscore salary. By calling df.salary.alias employee underscore salary, we assign a temporary alias to the salary column that will be used in the result set. This new alias provides a more descriptive name which can be useful for improving readability, especially in complex queries or reports. The rename column helps convey more context, indicating that it is specifically the employee's salary, which may be important when working with data that includes similar columns from multiple sources. We use the select function to choose the columns we want to include in the final data frame, employee underscore id, name, and the alias employee underscore salary. By renaming the salary column in this way, we enhance the clarity of our data frame without modifying the original schema. Finally, we call the dot show method to display the update data frame, which now includes the employee unders, read, name, and employee underscore salary column. This example demonstrates how using alias can make your data more intuitive and easier to understand, especially when preparing output for reporting or sharing with others. 2. Renaming multiple columns. In this example, we are working with a PySpark data from D that contains employee information, including columns for employee underscore id, name, and salary. We start by creating the data frame using the create data frame function, which helps us organize employee details into structured columns, making it easy to analyze and perform various operations. To make the column names more concise and descriptive, we use the alias function to rename multiple columns in the data frame. Specifically, we rename the employee underscore id column to ID and the salary column to emp underscore salary. Using df.employee underscore id.alias ID and df.salary.alias and underscore buscoseller allows us to assign temporary aliases that will be used for the duration of the current transformation. This approach is helpful when you need to simplify column names or provide more context, making the data easier to interpret. We use the select function to choose the columns we want to include in the final data frame. The renamed employee underscore id as ID, the original name column, and the renamed salary as emp underscore salary. By doing this, we create a more user-friendly version of the data frame, making it more readable and informative. Finally, we call the dot show method to display the updated data frame, which now includes the ID, name, and emp underscore salary columns. This example demonstrates how using the alias function can effectively enhance the clarity and presentation of your data by assigning meaningful or simplified names to columns. This is especially useful in situations where the original column names are long or not descriptive enough, or when you are preparing the data for reporting or sharing with others. 3. Using alias with expressions. In this example, we are working with a PySpark data frame D that contains employee information including employee underscore id name and salary. We create the data frame using the create data frame function, which allows us to organize the employee data into structured columns, making it easy to work with and manipulate for further analysis. To calculate an increase in salary and present it with a meaningful name, we use an arithmetic expression combined with the alias function. Specifically, we want to increase each employee's salary by 10%, and we achieve this by using the expression df.sale multiplied by 1.1. The result of this calculation will be used to create a new column named increased underscore salary, which we define using the dot alias increased underscore salary method. By using alias, we can assign a descriptive name to the calculated column, making the data frame output more informative and easier to understand. We use the select function to specify which columns we want in the resulting data frame. We choose employee underscore id and name from the original columns and add the new calculated column as increased underscore salary. Finally, we use the dot show method to display the updated data frame, which now includes each employee's ID name. This approach allows us to clearly show how much each employee's salary would be after a 10% increase, making the resulting output more insightful. This example demonstrates how to use alias effectively in combination with expressions to add new calculated columns while giving them meaningful names. Using alias makes the new column's purpose immediately clear, which is particularly useful for presenting transformed data, creating reports, or sharing the results of calculations. By providing a descriptive alias, you ensure that your data frame is both informative and easy to interpret, especially when complex transformations are involved. 4. Using alias in aggregations. In this example, we are working with a PySpark data frame T that contains employee information, including employee underscore id name and salary. We create the data frame using the create data frame function, providing structured employee data they can analyze and transform. To calculate the total salary of all employees, we use the sum function from pyspark.scol.functions. The sum salary function calculates the sum of all values in the salary column, giving us the total salary for all employees in the data frame. Since this aggregated value represents a summary metric, we use the alias function to assign a descriptive name to the result. By using .alias total underscore salary, we rename the result of the aggregation to total underscore salary, making it immediately clear what the calculated value represents. The alias function ensures that the aggregate output has a meaningful name, which helps make the data more interpretable, especially when working with summary metrics. We use the select function to include only the aggregate column in the resulting data frame, which now contains a single value representing the total salary of all employees with the column name total underscore salary. Finally, we call the dot show method to display the output. The resulting data frame presents the total salary, making the information easy to understand and use for further reporting or analysis. This example highlights how the alias function can be effectively used to assign a clear and descriptive name to the result of an aggregation, improving readability and ensuring that the purpose of the data is clear. This is particularly useful when creating summary metrics or reports where using meaningful labels helps convey the context of the data at a glance. 5. Using alias with grouping. In this example, we are working with the PySpark data frame DWAD that contains employee information, including employee underscore id name and salary. We create this data frame using the create data frame function, which allows us to organize the data into structured columns, making it convenient to analyze and perform operations on employee data. To calculate the total salary for each employee by grouping the data based on their name, we use the group by function in combination with aggregation. We start by calling df.group by name, which groups the rows in the data frame based on the unique values in the name column. Essentially, this step aggregates the data by each employee's name, making it possible to perform further aggregation on these groups. After grouping by name, we apply an aggregation function using X. Specifically, we use some salary to calculate the total salary for each employee group. Since our data frame is grouped by employee names, this aggregation will simply sum up the salaries of each unique name. Although in this example, each name is distinct, resulting in the salary itself. To make the aggregated column more descriptive, we use the alias function to rename the result as total underscore salary underscore per underscore name. This new alias clearly describes the information in the column, indicating that the value represents the total salary calculated for each name. Using a descriptive alias helps make the output more intuitive, particularly when the aggregate data will be shared or used for reporting. Finally, we call the dot show method to display the resulting data frame. The output contains the name column along with the new total underscore salary underscore per underscore name column, which provides the total salary. This example demonstrates how to use alias effectively in combination with group operations and aggregation to provide meaningful names to calculated columns. By assigning descriptive names to aggregated results, you ensure that your data remains understandable and easy to interpret, making it especially useful for data analysis and reporting. Thanks for joining me today as we explored how to use the alias function in PySpark to rename and clarify columns in your data frames. I hope this helps make your PySpark workflow smoother and your data transformations clearer. If you found this video helpful, be sure to hit the like button, subscribe to the channel for more data science and PySpark tutorials, and let me know in the comments if you have any questions or suggestions for future topics. Until next time, happy coding and keep your data organized.